Alright guys, now that we know a little bit about how to solve linear systems, let's use them to solve some linear applications. Okay, I'm going to start us off in the lab manual. They've got a collection of problems here. We're only going to work through a couple. They're really good problems to look at. So we've got an admission fee into a park. That's $150 per child. So that's important, right? $150 for a child and $4 for an adult. We know that 2,200 people, so that's people, adult and children, entered the park. Yeah. Total fees were $5,050. And it's asking how many children and how many adults entered the park. Okay. Well, first things first, before we can even write the equation, we have to define our variables. We have to let everyone know what is representing what. Well, what are we even looking for? We know that it's asking us how many children and how many adults entered the park, right? So it makes sense that that would be what we're looking for, right? So let's let X be the number of children. And let's let Y be the number of adults. Okay, now let's write our equations. What do we know? We know that admission is $150 per child and $4 per adult. We also know, in terms of talking money here, that the total amount that folks paid to get in was $5,050. So how can we use that? Well, we know that the amount paid for all of the children is going to be $150 for every child, right? How many children are there? Well, we don't know, but we're representing that by X, right? So the total amount paid for tickets for children is going to be $150 times X, right? $150 for every child. Similarly, for adults, we know that they pay for every one adult, right? Every one adult paid $4. So we know that the amount paid for adults is going to be $4 per adult, so 4 times Y. And we know that the total is $5,500. So the total is the sum of the amount paid for children and the amount paid for adults. We also know that 2,200 people entered the park total. So that should be the number of children plus the number of adults, right? So how can we represent that mathematically? Well, it would just be number of children plus number of adults is the total number of people who were admitted into the park. Okay. So 2,200. Great. This is our system of equations. We can either solve this using elimination or substitution. We're pretty easily set up for substitution, so let's go ahead and do that. It would be very simple for us to solve for either X or Y here. So I'm going to go ahead and solve for maybe X. So that would just mean moving Y over to the other side. So negative Y plus 2,200. And then I plug this into our other equation, right? I substitute. So I have 1.50 times this new expression. I distribute, I get 1.5 or negative 1.5y plus 1.5 times 2,200 is 3,300. plus 4y equals 50. 50. I can combine these guys and subtract this over. So I get 2.5y equals 1750, and then I divide by 2.5 and I get 700. Am I done? Nope, we want to use this to find x. We already know what x is in terms of y, so we can go ahead and just write that here. So x equals negative y plus 2200. We know that y is 700, so x must be 1500. Great. So we have 700 adults and 1500 children. That's our answer. Great, let's take a look at number 3 here. So a man, some guy, is investing his savings into 2 accounts. One pays 6%, the other pays 10% simple interest. All that this simple interest means is that we're just going to take 6% for 1 year and 10% for 1 year. That's all we're talking about. His annual interest, it's not going to involve that crazy equation, compound interest. So we know we have 2 accounts. One pays 6%, other pays 10%. And it's simple interest per year. He puts twice as much in the lower yielding account because it's less risky. His annual interest is $3,520. What are we looking for here? Well, it's asking us how much did he invest at each rate. So how much did he invest at rate 6% and rate 10%? So let's make some variables for those. So x can be the amount invested at 6%, and y can be the amount invested at 10%. So let's write our equations with these variables. The first part of the problem is telling us again that one is paying 6% interest and one is paying 10% interest. So how would we calculate the amount of interest earned on the amount that he invested? If he invests some amount of money, right, x, we don't know exactly what it is, but we're representing it with x. If he invests x dollars at 6%, we can calculate how much interest he's earning by taking 6% of x. How do we find 6% of x? Well, we multiply by 0.06x. How do we find the interest that he earns at 10%? Well, similarly, we just take 10% of y. The amount that he earns at 10% plus the amount that he earns at 6% is going to be his total annual interest. What is his total annual interest? Well, the problem has told us that it's $3,520. What else do we know? We also know that he's investing twice as much in the lower yielding account, the lower yielding account being the 6%, right? It's going to earn him less interest. He's putting twice as much in the lower yielding account as in the higher yielding account, right? So we have 2 options. We know that either x is 2 times y or y is 2 times x, right? Which one is it? So he's putting twice as much in the lower yielding account. So which one is going to have more money in it? X or y? Well, he's putting more in the lower yielding account, so x is going to be bigger. So does that mean we have 2x equals y? it doesn't. The way I like to think about it, because this can be confusing, the way I like to think about it is we know x is bigger, so in order for it to be equal to some function of y, we have to make y bigger, and we make y bigger by multiplying it by 2. So we have x equals 2 times y. Now we just have to solve these equations. What are we already totally set up for here? We're set up for substitution, right? We've already solved for x. So let's go ahead and plug this guy into our other equation. So 0.06 times 2y plus 0.10y equals our annual interest. We've got 0.12y plus 0.10y equals 3520. So we end up with 0.22y equals this. And we can divide. We end up with 16,000. That is a lot of money. $16,000. Okay, and now we have to find x, but again, we already know what x is in terms of y. We know that x equals 2 times y, so we know that x is 2 times 16,000, so x is 32,000. That is also a lot of money. So he's investing 32,000 at 6% and 16,000 at 10%. That's the answer. Okay, this is not in the lab manual, but I would like to talk about this type of problem. It's going back to sort of the fencing stuff that we talked about in polynomial modeling. So we want to build a fence. We want to build a pen for some animal, I don't know. I want to talk about the different ways that we can write down functions to represent the outer length of something like this, or the perimeter, or whatever it's asking for. So let's say we have 800 feet of fencing. All right. Well, we've talked about a lot of different shapes for this, right? We've talked about shapes that are just plain old rectangles. We've talked about shapes that have sort of dividers in the middle. We've talked about shapes that have had only 3 sides, and maybe there's something else that's making the 4th side. Well, how could we represent the perimeters of each of these, the amount of fencing that we need? Well, here, for each of these, we know that we have 800, so our total amount of fencing needs to be 800 equals something else. Let's say we've got width and length for each. Right, so we have this width, this length. They may not necessarily be equal in each case, but we're just going to try and write it different ways. So here, the 800 is going to be width, length. What is this amount here? This is another W, right? They're across from each other, so they have to be equal. Same thing here, this has to be L. So we've got W, L, W, L, which means we have 800 equals 2W plus 2L. Here, what do we have here? What's different? We've still got these same lengths on the outer edges. We also have this other length here in the middle, this other amount here in the middle. How long is this? It's also W long, right? Because this is a rectangle, all of these have to be the same. So in this situation, we don't just have 2 W's and 2 L's. We still have 2 L's, but we have 3 W's. So this one is 3W plus 2L. Here we have WLW. This side is not there. We don't need fencing on that side. So we just have 2W plus L. These are some examples, hopefully getting us warmed up. I wanted to sort of make this condition. So we want to build it against a house, so one side doesn't require fencing. With a barrier in the middle. As shown. I'll draw the diagram in just a second. And the last thing I would like for us to add is that the long side parallel to the house is 50 feet longer than the short side. Okay, so this is a lot of information to work with, but let's give it a shot. So the diagram that we have here, so we've got, that's our house. I'm going to make it sort of squiggly so we can tell the difference. We've got our longer side being parallel to the house, right? Across from it. And then we have this barrier in the middle. So this is our diagram. We've got W and L. So what other sides can we label? Well, we know, of course, all the way across is going to be W, and then this length is going to be what? W as well. So how can we write this? We know we have 800 feet. How many W's do we have? 3. How many lengths, how many L's do we have? Just 1. All right, that's one of our equations. What else do we know? Well, the next thing we know is that the long side, so this side, parallel to the house, is 50 feet longer than the short side. So L is longer than W. How can we write this? Is this L plus 50 equals W? Well, again, just like last time, let's think about which one's bigger. So the long side is obviously L, so L is going to be longer. If L is longer and I add 50 to L, is that going to be equal to something that's smaller? No, right? We need to add 50 to the smaller thing in order to make it equal to the longer thing. So we have L equals W plus 50. Great. Now we can use this to solve our system. This is our system here. Do we want to use elimination or substitution? Well, it looks like we're pretty easily set up for substitution, so let's go ahead and substitute in for L. We have L on its own already, so we can substitute for L. So that would give us 800 equals 3W plus, instead of L, we want to replace that with W plus 50. And that gives us 4W plus 50. We subtract that 50 over, we get 750 equals 4W. We divide by 4. We end up with 187.5 feet. Are we done? Nope, we've got to find L, but we already know what L is in terms of W. So if we know that L is W plus 50, and we know that W is 187.5, then we know that L is 237.5 feet. And this is our answer. Okay, let's look at one with 3 variables. Okay, this is an interesting one. A grocer is selling peanuts at $2.80 per pound. That's actually important here. Pecans at $4.50 per pound, and Brazil nuts, didn't mean to circle that. Brazil nuts at $5.40 per pound. He wants to make a mixture of 50 pounds, mixed together to sell at $4.44 per pound. The mixture should have as many Brazil nuts as peanuts and pecans combined. So how many pounds of each type should he use in the mixture? All right, so this is number 6. Well, we've clearly got X, Y, and Z here, and we want to know how many pounds of each. So pounds of peanuts, pounds of pecans, and pounds of Brazil nuts. Okay, so, well, first of all, kind of the easiest one is that we know that we want to have 50 pounds total. So the pounds added up, right, the amount of each should add up to 50. So our first equation, pretty simply, is just X plus Y plus Z equals 50. Our second equation is a little bit more tricky. So we know that if we're paying $2.80 per pound of peanuts, if we multiply that by the amount of peanuts that we're using, we should get the total cost of peanuts for the mixture. Similarly, if we multiply the $4.50 times the amount of pecans, we'll have the total cost for pecans for the mixture, and $5.40 times Z will be the total cost for Brazil nuts for the mixture. So if we add all of these together, what is it going to give me? Well, it's going to give me the total cost of the mixture, right? Is the total cost of the mixture for all of what he's making, right? Which is how much? How much is he making? He's making 50 pounds. Is the cost of that going to be $4.44? No, it's going to be a lot more than that, right? It's $4.44 per pound, but we have 50 pounds. So the total cost of the mixture is actually going to be $4.44 times 50. And then our last equation, the mixture is to contain as many pounds of Brazil nuts, so Z should be equal to the amount of peanuts, which is X, and the amount of pecans, Y, combined, so added. So Z is equal to X plus Y. All right, where do we start? Well, there's a lot of different ways we could start, right? We always want to start by eliminating a variable. for elimination, remember we always want to have everything sort of lined up. So let's get everything lined up nicely. So we've got x. I'm going to give everything a lot of space. I'm going to take that extra 0 off the end of these just to save some space. 5.4z equals 50 times 4.44 gives us 222. And then lastly, we want to line this up with the others. So we want this x and y to be on the same side with the z. If we bring the z over, we have minus z over here equals what? Well, if we brought the z over, there's nothing left, so 0. Well, we noticed that it would be pretty easy for us to eliminate z here, right? So let's add these two guys together. So we are eliminating z. So x plus y plus z equals 50, and x plus y minus z equals 0. So then 2x plus 2y plus 0 should equal 50. So we've got to eliminate it out of this equation as well. So that gives us 2.8x plus 4.5y plus 5.4z is 2200, kind of squishing, sorry. Now, in order for this term to eliminate this term, we need them to have same coefficients with opposite signs. They already have opposite signs. What do we need to multiply this last equation by? Well, 5.4, right? If we have positive 5.4, we want negative 5.4, we have to multiply this equation by 5.4. So, times 5.4, we get 5.4x plus 5.4y minus 5.4z equals 5.4 times 0, so 0. We add these guys together. We get 8.2x plus 9.9y equals, right, plus 0 equals 2200. Now we have a new 2x2 system with these two equations that we've just created. Oh, this should be, and this should be 222. How can we eliminate here? Not quite as simple as before, but maybe let's look at these guys, right? We've got 8.2 and 2 times x for each. How can we get them to be equal coefficients with opposite signs? Well, 8.2 divided by 2 is 4.1. So if we multiplied this guy by negative 4.1, we'd have negative 8.2x, and they would cancel. So negative 8.2x minus 8.2y is 4.1 times 50 gives me 205. And this one comes right over, so we have 8.2x plus 9.9y is 22. This should also be negative. We add these guys together, we get 0, right? These guys have been eliminated. We've eliminated x. We end up with 1.7y, and lastly 17. So y here is 10. We use this 10 to continue solving. Right now we're still working on solving the 2x2 equation. right? Remember, you always break it down into a 2 by 2 equation, solve the whole 2 by 2 equation, and then go back to the 3 by 3. So we use this 10 in this 2 by 2. We know that 2x plus 2y equals 50. We know that y is 10, so we have 2x plus 2 times 10 equals 50. We know that that's 20. If we subtract 20 over, then we know that we have 2x equals 30, or x equals 15. So we've now solved for both variables in this 2 by 2 equation, so we can go back to the original stuff. We know that z is equal to x plus y, so z is 15 plus 10, or 25. So we have 15 pounds of peanuts, 10 pounds of pecans, and 25 pounds of Brazil nuts. That's the answer. That's all I have for y'all for linear modeling. Thanks, y'all.